Adding and subtracting rational expressions is very similar to adding and subtracting polynomials. When we add and subtract polynomials, we look for like terms. So our first term here is 2x. We want to put that together with any of the other x terms in the equation. So in this case, negative 3x. Now we know that positive 2 and negative 3 is going to give us negative x. Then we move on to the y terms. So we've got a negative 3y and a positive 1y. That's going to give us a negative 2y. And finally, we've got positive 4 and negative 3. That's going to give us positive 1. Now notice none of the x terms can go with the y terms. None of the y terms can go with the whole numbers. So there's three separate types of terms here, and we have three separate terms in our answer. It's very similar when we look at radicals. Now here we have 5 root 6, and we're going to take away 2 root 6. Now if you think of the root 6 like a variable, because it behaves the same way, we've got 5 root 6's, we're taking away 2 root 6's, we're going to be left with 3 root 6. So the radical always stays the same, you just add or subtract the coefficients. In this example, we don't have the same radicals, so we can't put them together as they are, but we may be able to simplify them and have it work out that way. So the first thing I'm going to do is I'm going to take 128 and I'm going to break it into a product of its primes. So I've got 2 and 64, which can be broken down into 8 and 8, which is 2 and 4, and 2 times 4, and we get 2 and 2. I'm going to do the same thing to the 16. I'm going to break that down into 4 and 4, and we get 2 and 2. And the 54 I can break down to 6 and 9. I get 2 and 3, and 3 and 3. So because they are a cube root, I'm looking for groups of 3. So here's a group of 3, here's a group of 3, there's a group of 3, and there's a group of 3. And I'm going to simplify my radicals. So I can take out the 2 groups of 2, that will give me 4 cube root 2. Then if I look at the 16, I can take out one of the groups of 2, that's going to give me 2 cube root 2. Finally, the last one, when I pull out the 3, I get 3 cube root 2. Now you see we have all of the same types of radical once we've reduced it. Now this isn't always the case, but it worked out this way in this example. So we've got all these cube root 2's, we can combine the coefficients together. So 4 minus 2 is 2, minus 3 is going to be negative 1, and you can write the 1 if you want, but it's not necessary. So I get negative cube root 2. A final example with just numbers. Here I have 20, 18, 45, and 50. Clearly these are not all like radicals. We're going to see if we can reduce them. So the 20, I'm going to use the perfect squares method this way. 20 is 4 times 5. 18 is 2 times 9. 45 is 5 times 9. And 50 is 25 times 2. So I thought of a perfect square that can divide nicely into all of these. And then I take the square root of that perfect square. So I've got 2 root 5 plus 3 root 2 plus 3 root 5 minus 5 root 2. So now I have some that reduced so that they had a root of 5 and some reduced so that they had a root of 3. So I'm just going to combine my like terms together. The root 5's are going to go together, and we know that 2 plus 3 is going to give us 5 root 5. And we know the root 2's can go together. 3 minus 5, I should put minus here, is going to be minus 2 root 2. Now for the final example, we're going to look at what happens when we have variables. Now it's a square root in this example, so we need to define that x must be greater than or equal to 0. X can't be negative in this case, or our answers would be undefined. So because it's all root x, all I need to do here is just combine my coefficients. So I've got 5 plus 3 is 8 minus 4. That's going to give me 4 root x. Notice how the radical has not changed? Only the coefficients in front are added. Our final example, I just need to simplify here a little bit. Square root of 25 is 5, so I can pull that out. Square root of a squared is a, and I'm left with root b. I can do the same thing on this side. Square root of 4 is 2. Square root of a squared is just a. And I get root b. Now I do have to indicate that b must be greater than or equal to 0, because b cannot be a negative number. And I'm going to combine my like terms. So I've got 5a and 2a is going to give me 7a root b as my final answer. So when you're simplifying radicals, make sure that you're looking for radicals that are the same. And then once you've got radicals that are the same, for those ones, you're just combining the coefficients or the number that's out front.